Good morning. Today we will learn about arrays. The first data structure, array. We have learned about array in the third semester. Lot of things about an array. But today we will just refresh what we have already learned and also some points which we have missed there. Or we will look into array in the view of a data structure. How an array is successful in the point of view of a data structure. Okay, so what an array is? We know that array is a finite ordered collection of homogeneous data elements. These data elements have similar data type. These elements are stored one by one in consecutive memory locations and are referenced by an index. We know that the index is also known as a subscript. For example, an array of integers to store the age of all students in a class. The array of strings of character to store the name of all villagers in a village. These are all examples of arrays. We know that array can be one-dimensional, two-dimensional, three-dimensional, etc. In the case of one-dimensional array, we will have only one subscript. In the case of two-dimensional array, we have two subscripts. In the case of three-dimensional array, we have three subscripts, and so on. This is an example which we already know, but for the namesake, we'll just go through these things. We know that we have to declare an array using type and name of array. Int mark 50. Int is a data type, mark is the name of the array, and 50 is the size of the array. Okay, here the index starts with 0, so we can store elements from mark 0 to mark 49. Okay, we can take elements in these indexes as well. Using this index, we are accessing the array. Is that clear? We know that arrays are of fixed size. Data elements are stored in continuous memory locations which may not be always available. So, insertion and deletion of elements require shifting of elements from their positions. Is that clear? We can insert element in one position and delete element from another position. So far, we never thought about in this way. In all our previous programs, we are reading elements all at a stretch and try to write into the array and take the elements, do some processing and print the result. Okay, what we have bothered is the size of the array. Suppose we have declared the array size 10 and we are trying to access the 11th element, it will raise error. We are concerned about only about that. But now our consideration is not just that. We have to insert element into the array at any position. Also, we have to delete element from the array from any position. Okay. Array can be one-dimensional, two-dimensional, or three-dimensional. We have already said. Okay. Now see what are the operations possible on arrays. We can traverse an array. What does it mean? We are going to access each and every element for a specific purpose, which we have already seen. We have done many programs using traversing an array. Second one is insert an element into the array. What we have done so far is we have inserted elements into the array. Okay, at the full position to make the array full. Now we can insert element at any position in the array. We can insert element at the beginning of the array. Just we take one element, we try to insert at the beginning. Okay. Same way we get an element, try to insert at the end. Similarly, we can insert this element at any particular position, provided the array is not full. Now consider this. We have an array. The array has 10 elements. The array can store 10 elements. Okay, array is not full. We are going to insert an element at the fifth position. Okay, imagine there's an element at the fifth position. There's an element already there at the fifth position. What we have to do? We can replace and write, making the previous element lost. Or what we can do is we can shift this element to right and fill the element at the fifth position. We place our element at the fifth position and push this element to the right. Usually when we sort the element, we have a sorted array. We have to insert another element to the array. Again, the array should be sorted. So what we have to do, there's a particular position. Only at that position we can insert this element. So what we have to do, we have to push all other elements towards the right, make a room for this new element and insert this element there. Okay. The same thing is applicable when we are trying to insert. Okay, insert at the end is okay. The same thing is applicable if you are trying to insert the element at the beginning. There will be five elements there. Suppose you want to insert the one element at the beginning, what do you have to do? You have to push this five element to the right to make a room for this new element. Such difficulties there with an array. Now consider deleting an element from an array. We can delete an element from a non-empty array from the beginning, from the end, or at a particular position. Here, if you are trying to delete an element from the end, there is no issue. Okay, but suppose you are trying to delete an element from the beginning, what will happen? We can delete the element, but that space is vacant now. We cannot make any position vacant. We have to fill it. So what you have to do? You have to take each element at the right and push it so that we make the entry at the end. So this much operation is there. Similarly, suppose we are going to insert at a particular position. What you have to do? You have to that space is now vacant. You have deleted it. That element should not be there in the array. So you have to fill this element by pushing all the elements to the all the elements to the right to this position. Okay, we have shift one element to the right like that. It will be somewhat like this. Suppose this is an array. This is an array. There's already four elements here. Okay. Okay, let the array, this is index 0, index 1, index 2, index 3. Now I have an element 9. I have to push it into this array at position 2. What do you have to do? This is a position. This is a position for this array. Already 4 is there. What do you have to do? You have to push the 4 towards this side and make this space clear. 4 pushed. Then we can insert 9 here. So our array now becomes 2, 3, 9, 4. Okay, this much operation should be there when we are trying to insert an element. Similarly, you are going to delete an element. Suppose we are going to delete this 3. So what happened? 2, 3 should not be there. So we cannot delete like that. What we have to do is we are replacing this with this element. So we are pushing 9 towards this. So 3 is replaced by 9. Again, now push 4 towards this. So 9 is replaced by 4 and make this entry free. Fine. Make the point. This is the end. Noting this as the end. So this much operation is there with deleting an array. Okay, we will see the programs. So in that case, we will discuss operation once again. Now, next is searching an element from an array. It's okay. We can search whether the element is present. If the element is present, we say element is there at position this. Otherwise, we'll say the element is not there. Okay, that's okay. Next is merging two arrays. What is merging two arrays? You have to merge two arrays and make one. Merge two arrays into one. Next operation is sorting an array. We can sort an array in ascending order or descending order. These are the operations possible on array: traversing, inserting, deleting, searching, merging, and sorting. So we will write programs for all these operations. Some of them we have written in the previous semester, others we will write in this semester. Now we'll just go through one-dimensional array. What's the peculiarity of a one-dimensional array? It has only one subscript or one index. Only this index is required to reference all elements in the array. Okay. We know that the index starts with 0 in the case of C, but it is different in different programming languages. Okay. Now we'll see how can we address a one-dimensional array, how it is stored in memory. This is character str6 hello. This is the word. This is a character array. Its name is str. How many elements we can store here? 0 to 5. So this is the index 0, 1, 2, 3, 4, 5, 0 to 5. What's the value? HELLO, HELLO. And this is a character. We know that at the end we need a /0 symbol. Okay. Now what about the memory address? Suppose this is the memory address at str0. Means you should know this. Suppose this is 1000, this will be 1001. Why? Because character requires 1 byte. That requires only 1 byte. This will be 1002, 1003, 1004, 1005. Okay. Now the value 1000 memory address is 8280. This is a pointer. Suppose we are declaring character ptr is equal to str. We have learned what a pointer is. Just try to refresh it. We declare a character pointer to str. What is that? ptr is a pointer to str. Str means str, the value of str is 1000. So ptr contains 1000. The address of ptr is 8280. Its value will be 1000. ptr contains the address of str. Address of str means address of an str0. This means that ptr is equal to an str0. What is the address of str0? Address of str0 is 1000. So in ptr we are storing 1000. This is the pointer notation. Okay. Now what we are going to learn is the array addressing. Using an array addressing, we are going to access each element. Let the base address is equal to an str0. str0, this is 1000, right? This is 1000. str of I, any element in this array will be base address plus I. For example, str4 is equal to base address. What is base address? It is 1000 plus I. I means 4. 1004. Check whether it's okay. This is str4. This is str4. str4 is 1004. This is how we address. Base address plus I. stri is equal to base address plus I. What is base address? Base address is equal to an str0. This is how we address elements in a one-dimensional array. Okay. Similarly, we are going to learn about 2D array. 2D array is also known as a matrix. We have a set of rows as well as set of columns. Here we have 3 rows and 3 columns. We can write 3 by 3. 3 by 3 matrix. Now, how do we store a 2D array? 2D arrays are also stored in continuous memory locations. Okay, continuous memory location, just as in the case of a one-day array. If we know how to store a one-dimensional array, in the same way we are storing a two-dimensional array. There are two methods of storage, row major order and column major order. What is row major order? We are storing this element row by row. First row, second row, third row, row. That is, the allocation will be somewhat like this: A00, A01, A02, A10, A11, A12, A20, A21, A22. This is row major order. This row major order. Now, in the case of column major order, what happened? We write column by column. First column. That is A00, A10, A20, A01, A11, A21, A02, A12, A22. This is known as column major order. Column major order. In both cases, this is just like a one-dimensional array. Okay. This is the example or demonstration of a 2D array addressing. Look at the array. Int number 3, 4. This is the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 4. That is here you have 3 rows and 4 columns. 3 rows, 4 columns. Okay, this is the representation. We have 3 rows and 4 columns. This is how we write it. That is num00 will be 1, num01 will be 2, 02 will be 3, 03 will be 4, like that. Okay. This is represented in row major order. That is first row, second row. Look at this row major. This representation is row major. Majority of the system uses row major order. Row major. First row, second row, third row, fourth row. First row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, this is the value. This is the address. The base address is 1000. How it become 1002? Any idea? Because this is an int requires 2 bytes. The earlier it was character that require only 1 byte, so 1000, 1001, etc. But here this is, what is this? This is an integer, it requires 2 bytes, so the addressing will be 1000, 1002, 4, 6, 8, 10, 12, etc. Okay, this is the first element addressing. What's the base address? Base address means address of the first element, address of this base address of the first element. That is, this is the base address. 1000 is the base address. Okay, 1000 is the base address. Now, suppose you want to access any element in the array ij. Here is num ij. It is equal to base address plus I into number of columns plus j into size of the data type. This is the formula for computing the address of any element. We'll check A11. This is num11, num11, num11. Okay, address of num11. We are going to find out the address of num11. But base address? Base address is 1000 plus the value of I, this is I, this is j. Value is I is 1 into, how many columns? Number of columns, 1, 2, 3, 4. There are 4 columns, 1 into 4 plus j. What is the value of j? J is again 1. This is the base addressing formula. That is 1 into 4 plus 1, 5. That is after 1000, the fifth element. 1, 2, 3, 4, 5, fifth element. How do we get the fifth element? We have to multiply this with the size of int. That is 1000 plus 5 into 2. 5 into 2 is 10. It will be 1010. 1010. 1010 is 6. This is 6. A11 is equal to 6. Is it clear? What you're doing? We'll try to do once again. Num 21. That is what you have to do. First base address plus I is equal to 2. This is I. This is j. I is equal to 2 into number of columns. Number of columns is fixed. It is 4 plus j. J is again 1. 4 into 2 is 8 plus 1, 9. 9 into 2 is 18,000. 18. What is 1000? 18,018 is 10. Is it? This is 20. This is 21. A21. Okay. This is how we get the two-dimensional. We are traversing each element in a 2D array. Okay, 2D array is stored as one-dimensional array. So the operations one-dimensional array is same as that in 2D array. There are two types of addressing. There are two types of representation: row major as well as column major. Majority system uses row major order. This is 3D arrays. 3D array is just like 2D array. In the case of 2D, there are two arrays. In the case of 3D, there will be three arrays. This is the first array, this is second array, this is third array. Here, look at the index. There will be three indexes. We need I, J, K, three indexes to refer each element in an array. See, this is the representation integer x, 2, 3, 4. Just write it like a one-dimensional array. We can write it like this. We can write it like this. For the system, there's no problem between these two because system is storing this as a one-dimensional array. It is for us, we are writing in row by row, column by column, etc. It's for better understanding of human. We are writing in that way. So if you write in this way or in this way, system for the system, there's no problem. But it is better for us. We will be able to identify quickly what is a representation. This is how it looks like. Accessing elements in a 3D array is similar to 2D arrays. The difference is that we have to use 3 loops instead of 2 loops. One loop for each dimension. Okay. Now the next concept which you are going to learn is sparse matrices. Sometimes this may be new to you. Sparse matrix is just like a matrix. But here the problem is that majority of its elements are null, not value, 0. Okay, look at this one. How many values we have? There's a value here, there's a value here, there's a value here, 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 There's a value here, there's values here, and there's a value here. All others are zeros. Zero means null, null or zero, or not relevant, not relevant. It's not, it's not something which we want. Okay, that type of matrix is known as sparse matrix. Usually, when we store a matrix or a 2D array, we are storing all the elements in memory. Okay, we have to store all elements in memory. But in the case of a sparse matrix, it's a wastage because majority elements are null. It is not relevant. So why do we store it? Okay, this is a wastage of memory. So we must devise a technique to store sparse matrix. Okay, the technique is devised to eliminate this null matrix. We need to store only the values. Okay, ഈ values മാത്രമേ ആവശ്യമുള്ളൂ. We need to store only these values. All others are not relevant. That is known as sparse matrix representation. Some well-known sparse matrices are triangular matrices, diagonal matrices, and tridiagonal matrices. Look at this one. We have sparse matrix, symmetric sparse matrix. Symmetry means whatever is applicable left side will be applicable to right side also. We have triangular matrix, lower triangular, upper triangular. In the case of lower triangular, there are two classifications, lower left, lower right. In the case of upper, we have upper left and upper right. Then there is band matrices, diagonal, tridiagonal, alpha, beta, band. Okay, these are the examples. Look at this one. This is upper left. That means values will be there only in the upper left corner. Only in the upper left corner we have values. Others are null. This is upper right, top right. This dash means values. We have values in the upper right. Lower left means the values in the lower left. Lower right, values in the lower right. All other elements are null. These are known as triangular. It looks like a triangle. Okay. Then diagonal matrices. Value will be only in the diagonal. Value will be like this. This is a diagonal matrix. Just like this. 2, 3, sorry. 2, 0, 0, 0, 2, 0, 0, 0, 5. This is a diagonal matrix. The value is only in the diagonal. Diagonal can be like this or like this. You can also write it like this. 0, 0, 0, 5, 0, 0, 2, 0, 0, 1, 5, 0, 1, 0, 0, 0. The value is only in this diagonal. Can be diagonal matrix can be forward diagonal and backward diagonal. Forward diagonal and backward diagonal. Okay, these are the diagonal matrices. Next is tridiagonal matrices. Just need to remove the ink which I have drawn just now. Tridiagonal, that is diagonal can be three. Main diagonal, diagonal to the right side, diagonal to the left side. That is, there will be three diagonals. Okay, we have matrix like this. There will be main diagonal, this smaller diagonal, this taller diagonal. This is known as triangular matrix. Tridiagonal matrix. It can also happen like this. Main diagonal, one diagonal towards this side, one diagonal towards this side. These are known as tridiagonal matrices. Next is alpha, beta, band matrix. This is same as similar to tridiagonal matrix. In the case of tri, there will be only three. This can be any. That means we have non-null elements only at alpha upper and beta lower. That is, here it is 3, exactly 3. Here it can be alpha this side and beta this side. This is known as sparse matrices. Okay, this is enough for today. Just study well. Thank you.